So hopefully you've got this handout. It was given out to you. We're going to complete the handout. We'll do the first 3 questions and you do the rest. What do we need today? We need a pencil. Okay, so make sure you get your pencil out. The handout. You don't need a ruler today. And your trusty calculator. So you need a calculating machine like this, a Casser, or any kind you can get. Okay, let's start off with the first table here. So again, don't forget to put your name, and you can hand it in at the end of class. Let's start off over here. What we're going to do is we're going to put the -3 into the x right there. So this -3 is going to go into the x. So it's going to go 3 to the -3. And same here, 3 to the -2, 3 to the -1, 3 to the 0, 3 to the 1, 3 squared, and 3 cubed. So we're going to go to our trusty calculator here. We're going to turn it on. We're going to figure out what that answer is. So we're going to turn with the on switch. We're going to go 3, and I have an exponent key, which is right here. So mine might be different than when yours is. Mine's this exponent key there. 3 to the exponent -3. Let's see what the answer is. 3 to the -3. So here we go, 0.037. So in here, 0.037. Do the next one. 3 to the -2. 3 at -2. It equals 0.1111. Make sure you don't use the minus sign. Use the negative sign. So make sure on my calculator, don't use this one. Make sure you use the little negative sign when you put it in. This one here. Okay, not the minus sign. Okay, 3 to the -1. 3 exponent -1. -1. 3 to the -1, 0.333. Okay, we've got another one here, 3 to the 0, 3 to the exponent 0. That's 1. So, by the way, anything to the exponent 0 is 1. Anything to the exponent 1 is itself, so we'll just write 3. Okay, next 3 squared is 3 times 3, so 3 to the squared, I can use the squared key. 9. And 3 to the power of 3 is 3 times 3 times 3. So 3 to the power of 3. We get 27. Going to put 27. Now we're going to graph this. So this is a function. It's called an exponential function, and we're going to graph it. So they're very simple ones. Now there you go, Mr. Scomer. How am I going to graph it? Well, take a look here. We're going to graph this 0 and 1. I can graph that point. I can't graph some of these decimals. It's going to be difficult. But I know I can graph 0 and 1. So I'm going to go down here, and I'm going to go to the 0, which is here, and go up 1. So I can graph that one. Okay, come back to the table. Let's graph 1 and 3. 1 and 3. So I go over here. I can go 1, 1, 2, 3. And then I can graph 2 and 9. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I got my point there. That's the 3 main points I can graph. Now, 27 only goes up to 18, so I can't graph that. Well, let's think. How am I going to graph this one? 0.333. So we're at -1 and 0.3. This is 1, so 0.333 is about here, right about there. And then the next one that gets even smaller goes here. The next one goes even smaller, but it doesn't touch or cross the line. So it doesn't go and cross and touch the line. Now we connect the dots. So we connect it like this, and we come up, and we come up through these dots. We connect it here. It's a curve, and then we put an arrow here. We keep going. We know it goes to 27, which is off our page, and we put an arrow up. So we put an arrow up there. There's an arrow that goes here, and there's an arrow down here. Now, this arrow down here, that one really down low. This line never goes below it. What we call this axis here is an asymptote. So this axis down here is called an asymptote. I'll write it out, asymptote. I better make sure I spell it right. Okay, one S, asymptote. It's a line, so in this case the asymptote, where this doesn't cross, the function doesn't cross. In this case it's x equal to 0, because it doesn't go below the x equals 0 mark. Okay, now we're going to graph the next one. So we're going to come up here, we're going to create our table, so we got 2 here. Over here we got 0.5, and then we insert this -3. And then we do the same here, 2, 0.5, -2, and then 2, 0.5, -1, and then 2, 0.5, 0, then 2, 0.51, 2, 0.5, 2, and 2, 0.53. Oops, there it is right there. I'm going to get my calculator here, or my calculator, and I'm going to type it in. So 2, and then I'm going to put bracket, 0.5, close the bracket, use my exponent key, and I'm going to use that negative sign there to the 3. I get 16. First one's 16. 16 right here. Next one, same idea. I go to my calculator or machine that does my math here. I put my equation in 2 bracket 0.5, okay, to the exponent, -2, and I get 8. Put my 8 there. Then I do the next one. So I get, let's make sure you can see it, 2 bracket 0.5, 2 bracket 0.5 to the exponent, -1, 4. Well, 0.5 to the 0 is 1, and 2 times 1 is 2. Or you can put it in the calculator. Let's do 2. Wait a second, you can do the next one. Look, 0.5 to the 1 is just 0.5. Half of 2 is 1, so I can do 1. Maybe I can find a pattern. Let's see, 16 divided by 2 is 8, divided by 2 is 4, divided by 2 is 2, divided by 2 is 1. I bet you that's 0.5, half, and half of a half is a quarter. Let's just double check that. Maybe I'm off. Let's see. We'll put 2, bracket, 0.5 to the exponent, 3. 0.25, and that's what I got here, 0.25. Let's start by graphing the first point, -3 and 16. My graph here, -3. There's -3 here. We're going to go at the -3 to the 16 where it meets and put a dot. See, 16, okay, -3. Next point, -2, 8, and then -1, 4. Let's do these down here. -2, we got to go all the way to the 8. 1, 4. At 0, I think we're at 2. At 1, okay, at 1, we're at 1. So at 1, we're at 1. And then we go half. At 2, we're at half. So halfway between these two. And then we're half of that, we're over here. Okay, we're even lower. So we've got all our points graphed. We connect, we get a line here. So, or a thing, we're going to connect it like this. I'm going to draw the curve here. It's going to curve around here, curve through this point, curve here, and whoops, make sure I curve it through there. And it's not going to go below that asymptote. It's going to stay above that asymptote. We're going to put an arrow there. It's going to go, but it's never going to go below that asymptote. We put an arrow. Okay, over here, this now. If you look at the function names, The first one's f of x, the second one's g of x. So the first one we drew was f of x, put f of x. This one g of x. Interestingly, the one like goes up quickly, rises, goes upwards quickly. Well, look at here, it has a 3 and it doesn't have a decimal. Now the one that has a decimal comes down this way. It comes down, it goes downwards. Okay, so one is increasing, and when it's a decimal, it's decreasing. Let's do the next one, last one, and you guys can do the rest. And you can hand it in at the end. So I'll do one more. This one here, let's see how it changes. See if there's anything different on this one. So again, 2. Now we got like a -2 at the end. We're going to do the same thing with the calculator. We're going to go 2 to the -3 minus 2, and then we'll go 2 to the -2 minus 2, and 2 to -2 minus 1, and 2 to the 0 minus 1. Oh, this would be 1 here. And then 2 to the 1 minus 1, and 2 to the 2 minus 1, and 2 to the 3 minus 1. Let's get our calculator out. So this refocuses a bit. Let's do the first one. 2, bracket, 2, close the bracket, to the exponent, -3. And then at the end we go minus, use the other 2. So this sign here, the first one, is a little negative, that little negative. And then the second one is actually the minus sign. So I actually use this minus sign. Okay, let's hit equals here. You get 0.25 on the first one. Oops, 0.25. So we'll put 0.25 here. And there's focusing it in. Let's do the next one. 2, bracket. Oops, let's clear that. Oh, maybe I didn't hit equals. Let's try that again. So 2, bracket 2, to the exponent, -3, minus 2 equals negative 1.75. Whoops. 2 to -3, so negative 1.75. Let's fix that. So I forgot to hit equals on the last one. This is negative 1.75. Negative 1.75. Let's try the next one. Okay, 2, bracket 2. Okay, exponent, -2 minus 2 equals negative 1.5. Let's do the next one. 2, bracket 2, exponent. Remember the little minus sign, the little one here? Okay, and then the big minus sign goes there. Minus, oh, not -1, but -2. It's going to do 12. Let's see if there's a little delete key. I can go back. Delete. -2. And we get -1. Okay, so let's do the next one. 2, bracket 2, to the exponent 0, minus 2. Whoops, I screwed up on my equations there. I can tell that's 0. So look, these should all be -2s, not -1s. All these are -2 in the equation. I'm not sure I put -1 there, but these are all -2. You're just replacing the x. Okay, let's do the next one. Well, the next one is 2 times 2 minus 2. 4 minus 2 is 2. Okay, let's do the next one. 2, bracket 2 to the squared minus 2. 6. Okay, let's do the next one. 2, bracket 2, the exponent, 3, minus 1 again. Oh, minus 2, what am I doing? 2, bracket 2, to the exponent, 3, minus 2, equals 14. Okay, I think we got them all here. Let's now graph it. So let's graph this last one. So I'll start with 314. So because I see it there, 3 here, 14, all the way up to 14. Next one, 2 up to 6. So 2 up to 6. Okay, so look, there's a 3, 14, 2, 6. Now I'll do 1, 2, and 0, 0. Okay, so 1 up to 2, 0, 0. Interesting, the next one, okay, the next one is -1, so it's -1, -1. The next one is -1.5, so it's down here. The next one's like -1.7 right there. Connect all the dots here. It doesn't go below that line, I'm sure of it. And come up here. Put an arrow there. Put an arrow on the end. Put an arrow here. Now, it doesn't go below this line here. This is the new asymptote. So it doesn't go below that line. That's the asymptote. Okay, in this case, it's x equals -2. Okay, it doesn't go below -2. So it doesn't go below the -2 at the end. The other ones didn't have anything, so it didn't go below the 0. Okay, we've got that drawn. We're going to call this one f at x. And now I want you to do the other 3 and hand it in. Okay, and that's it for my lesson.